All right, so we've been talking about electron configuration over the last few lessons. We're going to dive a little bit even more deeper into that. So remember our energy levels. So remember our energy levels are the relative distance away from the nucleus. 7 possible energy levels are also called periods. So periods, distance from at the nucleus. The outermost energy level is your valence electrons. So energy levels, electrons can jump back and forth between energy levels, or where they are starting is called the ground state, and moving up is the excited state. So this is when energy is pushed into these electrons, it will move or excite from that ground state. Energy becomes excited, it absorbs a photon of light, a quantum, 1 quantum of light energy. So as it becomes excited, it absorbs this photon. So as it jumps back down, it emits that light energy back. So we've been talking about how different elements have different light emissions because of how their electrons jump back and forth between their excited state and their ground state. So the photon is what is lost as it goes back down to the ground state. It is gained as it goes from the ground state to the excited state, and it is lost or pushed off or able to be visible when it goes from that excited state back down to the ground state. So remember, they can go back and forth between these energy levels. The frequency or color that corresponds to the distance in which it falls. So if it excites 2 energy levels, it can fall even further and show a different corresponding color or frequency. So we talk about the electromagnetic spectrum. We've talked about this a little bit in my physical science class. I'm sure you talked about it in Mr. Ford or Miss Selby's class. So there's visible light that we see. The visible light is the spectrum of the rainbow, that type of thing. So white light is put into a prism, and you can see these different colors. So the electromagnetic spectrum shows these colors based on how much or whatever the frequency, so how many energy levels these electrons are falling. So a spectroscope is an instrument that is designed for this visual observation. So the spectra, so the light electromagnetic spectrum or the light spectra is what we are focused on. So an example, when we look at a spectra, we would see that calcium has this specific frequency and sodium has this one. And if anybody's played like the Spider-Man games, they kind of do a play on the light spectra with one of their mini games in the new Spider-Man game. And then the atomic spectrum. So this is the common ones that we see in the atmospheres of stars. So iron, magnesium, calcium, hydrogen. This is what we'll see come out of those stars. That's why we see things like red giants, yellow dwarfs, things like that. So here's a spectrum of a mystery star. Which elements are present in this one? So if we look at it, we can look to see there's some magnesium. Looks like there is some calcium. We can see that there's probably some iron, but it doesn't look like we can see much hydrogen. See the darker lines? We don't see any hydrogen. There's not really iron either. See calcium, we see the calcium, and we see the magnesium, especially because of that dark line. So if we do this one, you can see the iron because there's your dark line. There's another one, and you see how this is all together. So we're looking at probably calcium because it has calcium as well. And I don't believe I see any hydrogen. Do you see any hydrogen? I don't think I see any hydrogen. So calcium and iron. So this would be how we would see what specific elements are burning in a flame or what is being cast off in a specific excited state of these elements. All right, this is how we would use the spectrum. It is that simple. All right, have a good day.